Now here we are going to find out about the relative and the absolute extrema, increasing and decreasing intervals of the trigonometric functions. So basic thing, today I am going to teach you how to find out the critical numbers of the trigonometric functions. Now before applying any idea, you should know the basic rules of to find the critical numbers of the trigonometric functions. So look at the coordinate plane. In this coordinate planes, which is the coordinate plane of a unit circle, at this side, the value of the x is said to be 1, whereas the value of the y will be considered as 0. When we move to the top, here the value of the x is 0, whereas the value of the y is 1. We move to the left hand side and the value here is -1 and 0. We are writing the values of x and y in the coordinate plane of a unit circle. And at this stage, the value of the x is 0, whereas the value of y is -1. Another important thing which you should know, that whenever we talk in the coordinate plane about the unit circle, we should know that we are talking about the x or y values. So x values are basically called the x cos x, whereas the y values are termed as sine of x. Now another thing, you should keep it in mind that here if we are talking about the one revolution, so here this is the 0. Now you are move to the top right, so the angle over here is said to be pi over 2 or 90 degree. You move on the other side, here the angle is 180 degree or pi radians. We move at the bottom, we get the angle as 270 degree or 3 pi over 2. We completed the one revolution and here the angle is now 2 pi. So at this stage, when x is 1 and y is 0, or in other words, cos x is 1 and sin x is 0, the angle means the x value is 0 and the x value is 1, whereas the y value is 0. So I think that you got this point. Now another thing, that if we get any of the angle, theta means we are talking about now angles. If we get any angle between 0 and pi over 2 or 0 and 90 degree, we will term it as theta. Now from the theta, we want to jump to the second quadrant. So at this stage, we will apply the formula pi minus theta. When we will jump to the third stage, here it will be pi plus theta. Now keep it in mind that theta remains the same, whatever you got from the calculator in the start after solving the x value. And here in the fourth quadrant, the formula will be applied as 2 pi minus theta. So these are the basic rules which we have to apply everywhere in the trigonometric functions while finding the critical numbers really. Now let's go to the next slide and have a look on an actual question. Now let's see an actual question, y equal to sine x. So as we know that in order to find the critical numbers, the first thing is to find the derivative. So the derivative of sine x is cosine x. Now after that we have to solve for x. It means make the equation of the derivatives equals to 0. So we will write cos x equals to 0. Now in order to find the value of x, we will write here x equal to cos inverse of 0. Now write it in the calculator. You will get cos inverse of 0 is equal to 1 over 2 pi. So this is the value which you get by the calculator. Now let's suppose I don't want to use the calculator. So what basic things I should keep it in mind? Here, look at the blue side. I wrote here cos of x equals to 0. Now what thing comes in your mind when you see cos of x equals to 0? that in the coordinate plane, the x value is 0. So I will ask myself how I will find this one. So I will go to the coordinate plane and I know that in the coordinate plane, where is my x0? So I have the x0 when the angle is pi over 2. I have also x equal to 0 when the angle is 3 pi over 2. Now before finalizing my critical number, I will have a look on my question where the closed interval is given that I have to take the critical number between 0 and pi over 2. And pi over 2 is included, 0 is also included. So yet see, our answer is pi over 2. So this is our critical number because 1 over 2 is included in this interval. Now, what if the closed interval changes to 0 to 2 pi? It means now you are talking about the whole circle. So you know that already you have found out that the first value is pi over 2. And if we go at the down where the cos x is 0, the other angle is 3 pi over 2. So we will write here the critical number as x equal to half pi and also x equal to 3 over 2 pi. So basically this is the idea to find the critical numbers. Have a look on the other question. So now in this question, basically the idea is same. So the question is y equals to cos of x. So the derivative of cos of x is negative sine of x. Now set the equation equals to 0. So we will write negative sine of x equals to 0. Bring the negative on the other side. So you will get sine x equals to 0. So what question I should ask myself? So does sine x represents x value or y value? So my answer is that it represents y value. So if it represents y value, the next question I will ask, where in the coordinate plane y is as 0 representing. So let's see here. Here I know that the y value is 0 at this point, and similarly at this point the y value is 0. Now here the angle is 0 and 2 pi, and at this side the angle is pi. So now I will go back to my question and I will see my closed interval before writing my answer. So here my answer is that from 0 till pi by 2, where is my critical number? So you can see that one answer is 0, one answer is 2 pi, and the last answer is pi. So between 0 and pi over 2, my only angle is 0. So I will write here the x equals to 0. Meaning I can jump directly and do this answer mentally also. But if you want to check the answer, what you will do? You will write here x equals to sine inverse of 0. So the answer is 0. So in this question, the calculator works. But what if the closed interval changes from 0 till 2 pi? It means you are talking about the whole revolution. So what you will do? You know, here you have 0 and here you have 0. So you have how many angles? You have 3 angles. One is 0, one is pi, and one is also one more, that means equals to 2 pi. So here at this stage you have 3 angles, 0, pi and 2 pi. So that's all.